Everybody has a periodic table available?
And the magnifying glass.
And a magnifying glass? Actually, I'm going to go to the periodic table as well. So we'll do it on the periodic table.
To be clear, you're saying this is chapter 4, right?
No, this is chapter, sorry, my mistake. It is chapter 5 and 11. So we're doing chapter 11.
It's
Yes,
homework 4, right?
Yes, it's homework 4.
Okay.
Thank you for the correction. I told you guys I'm old. I forget things, okay? You think I'm kidding? I forgot my name this morning, so. Okay, do you guys see my periodic table?
Yes.
Okay, this is the old version of the periodic table. So, okay, so I'm gonna go over it again. We're gonna start from the beginning and work our way through and see how much of it you guys remember. And you guys can help me along the way because this is an interactive type of situation. I learn from you, you learn from me, right? We talk. Okay, so let's talk about hydrogen. How many electrons does hydrogen have?
Just one.
It has 1 electron. Okay, so when we're doing electron configuration, guess what we're going to be concerned about? Take one guess.
Electrons.
1.
Electrons,
Yeah.
right? So we're going to be concerned about electrons. Okay, so since we're talking about the electrons, the way that we would write the electron configuration for hydrogen, let me.
1.
You're just getting anxious. Let me give you a little information first. So we have what we call sublevels. So there are 4 sublevels. We have the S sublevel, which holds 2 electrons. So I'm going to make a little s. We have the P sublevel, a little p, that holds 6 electrons. 6. We have the D sublevel, which holds 10 electrons. And then we have the F sublevel, which holds 14 electrons. Okay, I'm gonna, give me 1 second. I have a really bad image of the periodic table. For some reason, I got the old one.
I was studying this morning because of our group's activity.
Okay, so do a real quick recap. While I fix this. So we have S, which holds 2 electrons. We have P, which holds how many?
6.
6.
We have D, which holds how many?
10.
And F, which holds how many?
14.
Okay, so the periodic table, again, is set up in an order of, it's based upon a combination of energy and also how those electrons are going to be placed into the orbits, the different sublevels. So this first 2, group 1 and group 2, can I ask you guys, who's ever has background in the background, can you mute your?
That's probably me, sorry.
Okay, thank you. So the first 2 hold the S, the electrons that would be in the S orbital. This would be your P sublevel. This would be your D sublevel. And this would be your F sublevel. Now, I didn't repeat myself because I'm old. In this case, normally that would be the reason, but I repeated myself so that you guys can actually see. Okay, now somebody should ask me, and I'm waiting for it, right? And you're going to ask me, and then I guarantee you 5 minutes later, somebody else is going to ask me the exact same question, right? Did anybody count how many spots are here?
Dr. Henry, I'm sorry.
More than 14.
Can you put an S on the top there so I could screenshot
Oh,
that?
there's 10 on the
Oh, yeah.
second one.
Thank you.
Okay, I see it.
The first top are 14, but the LU is a 15, but wouldn't it be the D block?
That is correct. That is definitely correct. The LU and the LR, they actually belong to the D block. That is correct. Good job. Okay, so when we talk about electron configuration, we want to keep track of every electron that an atom has. You told me that hydrogen has how many electrons?
One.
What?
So we want to know where those electrons are at. And so this is kind of like an address book for that electron, right? So you guys all have addresses and we have zip codes and all that stuff. So electrons have the same thing.
Yes.
Can I ask a quick question?
You can ask a question.
Why does the LU and the LR belong to the D?
Because they just put it down here so that we know that you have the F right in front of the D. And if you look at it right here, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are your.
There's your 10th. Okay.
But actually they're your first. They're the first ones in the D orbital.
Okay, got you.
Okay. But that's the question. Okay, so let's talk about hydrogen. So we have hydrogen, and you told me it has 1 electron, right? So what we would do is we write the period that hydrogen's electron is in, that first electron, it's in what period?
The first, so
So we'd write 1. So then we would write the sublevel. That is, what sublevel is that?
S.
S.
And we tell how many electrons are there. How many electrons are there?
One.
1. So that's going to be your where your exponent would go, or your superscript, okay? So the first number tells me the period that electron is at. Then we have the letter of the sublevel, and then we have how many electrons are there. You guys got that?
Yeah.
Yes.
Yeah.
Okay. So let's say we had helium. Helium is He. How many electrons does helium have?
1.
2.
Oh, helium.
Helium has 2 electrons. So although it's over here, it's still considered to be the 1s because you want to fill up the s orbital before you go to the p orbital.
So helium will be 1 to the S2.
That's correct.
Fill up the S before you go to the
The p.
P,
Yes. In most cases.
and
There
so
will be
forth and so on.
exceptions, and I'll talk about those later. 99% of the time, you're going to fill up the S first and then go to the P. Okay? You got that? Okay. So then, let's say we have something like carbon. Carbon is located here. Do you mind if I erase? Or do you guys need the blocks to help you remember where everything is at?
I think it'll be okay. Can you just leave those 2?
Yeah, I can leave those 2.
Okay.
You sound like you're a little hoarse. You've been yelling? Yelling at your boyfriend, huh?
No, I just woke up.
Oh, okay. Okay, so we're talking about carbon. So the way that we would go about carbon, we start off with the very first one, the first electron. The very first electron is going to be in the 1s, right? Is the 1s going to be completely full?
Yes.
Can you guys hear me? I'm losing my internet connection there.
Yeah, we can. Yeah.
Can you hear me? Okay, good. Okay, so one way of doing it is, okay, so that's the 1s, and then
1s to the second, and then
it's 2s.
2s to the second,
That's right. So then
and
that
then 2p
Hear
to the
this?
second.
carbon is right here. So then we go 2p. To the second. That's correct. And so it takes where we want to be. Now you see that. So now we know where every electron is located at for carbon. How many electrons does carbon have?
6.
6.
Okay. So if we count those exponents or those superscript, it's 2, 4, 6. Okay.
6.
Do you see
So
that?
1s, 2s, 2p.
That's right. Piece of cake?
Yes.
You want to try one more? Or do you guys
Yeah.
have it?
No, not a piece
Can
of
we
cake.
try one
I'm
more?
thoroughly confused.
Yeah.
You're thoroughly confused.
Yeah, I'm sorry.
What,
I don't.
what are you confused about?
I'm not sure what we're doing here.
We're keeping track of all of the electrons, right? So how many electrons does carbon have?
Carbon has 6.
Carbon has 6. So carbon has 2 that are in the S1 orbital. The first period, the number there gives me the period. This tells me the S, that means it's being occupying this space. In this case, that's the same one as that helium that's over there. So that's the 1s. You can only have 2 electrons in the s orbital, okay? Then we go down to the 2p's. That's why we crossed out here. So that's the 2p. Then, I mean, not the 2p, sorry, the 2s. That's the 2s. Then we come over here to the 2p. Okay, so
Got it.
right there, 2 of them, because this is a p subshell right here. So the p starts at the second period. Okay, so that's your p. Okay, so let me give you another example. So then we can make sure that you guys got it in concrete. Okay, so let's do phosphorus. Okay, and Z, I want you to pay attention to what we're doing here. Okay, so you see where
Okay.
phosphorus is located at?
Yes.
So I'm going to go ahead and circle phosphorus.
It's located in the p. So that's
Okay, you see where phosphorus is located at. How many electrons does phosphorus have?
15.
15.
It has 15 electrons. Okay, so we need to keep track of 15 electrons. So each electron has a different address associated with it, right? So we start off with,
1
say,
and
a P.
1.
So in the first period, right, we go with the period first. So it's 1, and how many electrons can be held in the
S.
1s?
2.
2.
2.
Okay, so it's going to be full 1s2. So that counts, that gets rid of this guy here, this guy, helium. So that's your 1s. Then we have the second period. That would be the period 2s.
2s2.
2s2. So that counts for those electrons. And then we have over here, how many?
2p6.
6.
2p6.
And then 3p6.
Wait, no, you
No.
got to rate. It's not 3p6. You got
3s2.
3s2. That's right.
3s2.
So follow it, you know. Remember, it's like a typewriter. You have to come back to the other side. You guys don't know what typewriters are. I forget.
I did.
So we bring
Oh,
that
you
3
do.
back over here under the 1s?
That's right. So you'd have 3 S2.
So it's 1s2, 3s2,
No, 1s2, 2s2.
2s2, 2p6, 3s2.
Yep. And then over here we go. We're going to phosphorus, right? So that's 1,
3
2, 3.
3p3.
That's right. So if you just follow your periodic table, it tells you, and just keep track of it. Okay? Piece of cake?
Piece of cake.
Okay.
Yes.
So
Isn't that more than 15?
count. So 3p3, right? So that's 3 plus 2, that's 5, right? And then we have 6
12.
plus 2 plus 2. So that's 10. So that's 15 altogether, right?
Okay, yeah, it's 15. You're right.
And
I
that's
wrote
how
the
you confirm your
3p3
answer.
twice.
Yeah, you got to be careful of that. So if you just keep it in order, if you follow the trail, 3, you go down here, 3, and then you go 3, 3s, 3p.
Like you
Okay?
said, like a typewriter.
Exactly. Okay, so now I'm gonna make it harder, right? Now that you guys, I said I made it easy.
I'm sorry. Before we go harder, one question.
Yep.
So we went 1s2, right, which was the hydrogen,
That's right.
and
No, the
Did
hydrogen
that
only has
include helium?
1 electron. No. So this here, this helium,
uh,
is really over here, right? We just put it over here because it's a noble gas. It serves 2 purposes, right?
got it.
So only in the 1 period, they only have an S, and that's it. So that's 1s2 when you're talking about both of the electrons in the 1s shell.
That's what
Okay.
I thought. I just wanted to be sure that that helium was included in that 1s2. Okay.
Dr. Henry, for
Yep.
the sublevels D, I was
Yep.
watching a video on it, and I think, do they follow a different rule?
It
Like-
isn't a different rule. It's the same rule, but you got to start off at a different point.
They
Let
just
me
write it down differently.
Let me get there. Just hold your pants up. Hold on. Give me a second. I'm getting there. Okay. So as you were talking about, the d orbital is a little different. It starts off 1 lower than you would have for the s, right? So for instance, if we're in the 4th period, right, this guy is actually 3d. So you're going to start here, the very first one right here, that's going to be 3d, okay? And the F, if we get down to the F, it actually starts at 4F. Okay, so let me give you an example what I mean and what I'm talking about specifically. Let's say we had cobalt. You guys see cobalt right here?
Right?
Yeah.
Okay,
90.
so how many electrons does cobalt have?
27.
27.
27. Okay, so we're going to write the electron configuration for cobalt. So we write the element. We put a colon, and then we go through the process, that same process that we start out at. Let's see. So start at the top. Very first one is what? What period are we in? If we started at the top,
1h to the second.
1s2. Okay, so that takes care of these guys, those two. Okay, now what about these guys here?
2s2.
2s to the second.
2s2.
And then the next one,
2p6.
2p6.
3s2.
Okay, you guys are talking too fast. I can't write that fast.
and then 3p.
Okay, I'm telling him we're going too fast, and you just keep going faster. 3s2.
3p6.
And then 3p6. I'm going to start making you guys write this. See how fast you guys write. Okay, and then we get to the 4s, right? How many do we have in the 4s?
2.
4s2.
4s to the second.
Okay, now this is where it starts to get different, right? Because I told you that here we start at the 3D. So this would be our 3D. So it drops down by one number that the period is. So the period, we're in the 4th period, so we subtract 1 for that D, so then we're now in the 3rd period for the D. So you write 3D, and then how many are there for the 3D?
3d to the 7.
So that's 1, 2, 3, 4, 5, 6, 7. Okay, so 3D to the 7.
That's 27 right there.
Okay, piece of cake.
What happened with the 3Ds? What was it that was? You said it was going to get tricky there. What did we do?
Because we're in the 4th period, right?
Right.
So it's no longer 4. You don't put 4D, you put 3D. You understand? It actually starts.
And why is that?
Because what's happening is that the D shell is lower in energy than that 4s shell, right? I mean, sorry, the 4s shell is lower in energy than the 3D shell, right? So I'm going to show you a figure, and then we'll come back and talk about it a little bit later. But everything is going to be based upon energy, and the periodic table is organized based upon a combination of energy and also atomic number. And so the way it works is that the electrons actually will fill the 4s shell first before they fill the 3D. So normally D3 is lower in energy than 4, but you have an overlap between those two. So let me show you this. Let me find it real quick. So what happens when you have 80 windows open? Okay.
Jacob, start your schoolwork. Put your phone away.
Can you see it? Be clear. Okay, so this basically shows you the energy scale. So here we have the 3s, then it goes 3p, and then 3d is right here. This is the 4s. So 4s is actually lower in energy than the 3d. So we filled that one up first because the electrons want to keep a low energy profile, like you guys, right? Do you want to do any extra work, more extra work than you have to do? So if you could pass this class by giving me a smile and a handshake every day, what would you do?
Smile and handshake.
Smile
Ask
and
for
handshake.
more work.
What was that?
Ask for more work.
You would ask for more work?
Absolutely.
Okay, sure you would. Okay, so the electrons are very much like us. They want to try to keep a low energy profile. If they don't have to do any extra work, they're not going to do any extra work, right? And so that's the goal, to try to keep a low profile. That's also part of the reason why they want to do bonding, is because they want to keep a low profile. It actually will lower their energy state. Their goal is to try to have the lowest energy state that they could possibly have.
So 4F is increasing in energy.
So if we look, yeah, 4F is higher than the others, but let me see. Sorry, I got blocked out. So yeah, you can see 4F right now is the highest, higher energy state than the others. And so typically your energy state goes, S is going to be in the same period, like 2S is going to be lower in energy than 2P. And then 3P is lower than, let's say, 3D. But then you have cases where you have overlap, and that's all this is. It's just overlap. So what happens is that when it has a chance, it's going to fill up this guy first and then fill up the 3D. And so that's the reason why it's set up in that order. Do you guys understand that? So it's all about energy. So let me see. Go back to.
I just accept that we go through the S's before we go to the D's. And
You
work
go
our
to the
way up.
4S. You go to the 4S, and then you go to the 3D. And just
Right.
if you're smart, what you would do on your periodic table, and if it were me, I would write 3D right above it. So I remember that I start at the 3D. And then I would write 4F right above it. So I remember that it starts off at the 4F. Okay? So let's do one more. And then we'll switch it up a little bit. Okay, so let's do promethium. Okay, so let's do promethium. You see it down there?
61.
Yep. So what are we gonna do?
Start with the S's.
Well, you gotta be more
No.
specific.
Okay. 1S2.
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 2S2. 2P6. 3D7.
Wait, slow down.
No.
You see, 2p6. Okay, so that gets us all the way to the third period. What happens at the third period? And use the periodic table, because if you don't use the periodic table, you're going to do what Lorraine just did.
Is 3s2?
3s2,
Yeah. 3P6.
3p6,
Then down to 4S2.
2, yeah.
And then you're going to go over to your F.
3D,
3d,
10,
3d10, that's right. And then
4F.
4,
no. How are you going to go?
Oh,
You're
4p.
telling me, Lorraine, follow the periodic table. What's over here? Is this
It's
4f?
gonna be 4p.
No.
4p6.
It's 4p6.
And then you go to 5s squared and then to 4.
So 5s
4d10.
squared. So 5s2.
Okay.
Okay, so we're down here right now. So we just did 5s2. And then what's this guy over here, Lorraine?
That's the P.
4D.
It's
4D.
the D. It's 4D. 4D,
4D.
right? So remember, transitional
4D,
metals, these
10.
guys are going to be Ds. So 4D,
Oh,
4D
yeah.
what?
4D10.
4D10, okay? And then, so we've done 4D10 right here. So then
5p6.
5p6, and I'm running out of room. So I'm going to write up. I'm going to go this way. Okay, so then what's after the 5p?
6.
S2.
6s2.
6s2.
And then 5d10. And then 6 to the
Wait.
p.
Wait, slow down, slow
No.
down.
Oh.
So you said 5d10, right? So the D is right here, but the F comes before the D. So you
Oh.
forgot to
That
go
would
down
be
here.
F and F4.
Oh,
There you go, F for F. And how many are there?
2.
1, 2,
2,
3, 4, 5.
5.
So there isn't even a 5 there at all, right?
Dr.
Right.
Henry, is there like a shorter way to write that, or do we always have to go down like that?
Yes, there is a shorter way. God, you guys are, it's like I paid you money. It's like you're just,
but
we're
for
here.
the shorter way, we have to start in
This
the
is a
noble
good way to
gases.
learn it though, right?
Oh, it is a good way to learn it, right? But it's an easier way to write it. And I'll show you that way.
Do we have to
just-
start for the noble gases in the shortcut?
Yes, yes, yes. Okay, so let me explain something to you first. You guys are so ahead of the game here. You need to slow down. Just breathe a second. Let me talk. Whew. Okay, so as Jacinda was saying, it's about the noble gases. So the noble gases are going to serve as a core, right? Because remember, everybody likes to be like the noble gases. And once your noble gas, like once the electrons for a noble gas is completely full, it's kind of like putting a cap on. And anything over that is kind of extra, right? And those extra, which we call valence electrons, are going to be the ones that are going to be involved in reacting with it. So let me kind of explain it to you. So for instance, we have PM, right? So PM is located right here. So if we go back to the nearest noble gas, what is the nearest noble gas going backwards from PM? So here's PM. We're going this way, right?
X.
All the way this way. So then the nearest noble gas would be xenon.
Dion.
X.
Okay, so
X.
then that is going to be our core. So xenon would be our core. So we're saying that we have all the same electrons as xenon, and then we have these extra. So we would write it as PM bracket xenon and then we would, from there, just write down what we have afterwards. We'd have 6s2 4f5.
So we would
Okay.
we would always go from the nearest noble gas.
Not the nearest noble gas, the noble gas that you've passed. Because
Right,
sometimes
the
the
last
nearest
one,
noble
okay.
gas, yeah. So you've had to already pass it,
Okay.
okay? So you just go back to the nearest noble gas that you passed, okay? And that's gonna be important.
Is Rn a noble gas?
Yes.
So we didn't pass that?
No, we didn't pass it. We're right here. We're on the 6th level.
Okay,
Rn is
so
at the end of the
okay, on the
6th
fifth
level.
one. I got it. Thank you.
You're welcome. Okay, do you guys get it?
Yes.
Do you want to try one out?
Yes.
In the shortcut way?
The shortcut way. We'll try a
let's
couple
do
out
it.
the shortcut way. Okay, and on the exam, if you're ambitious and you want to sit there and do the extra work, you can do the long way, right? I don't care. That's fine. I'll grade it either way. Or you can do the shortcut way. I recommend doing the shortcut way because it saves me time and it saves you time and it keeps you from making those mistakes with the lower numbers. Okay, so let's try one. Let's try one that's hard. Okay, so let's do Einsteinium. So where's Einsteinium?
It's at the bottom. Number 99 has a 99 electrons.
99 problem and a,
A1.
okay. So 99 electrons. Okay, so where are we going to start? What are we going to do? You guys tell me. I'm
So
just your
is
secretary.
So it
radon?
would be RN
I'm just going to
Yeah.
write RN immediately. Am I going to write
brackets?
anything else? What am
No,
I talking
Well,
about?
not in brackets.
Oh, I
ES,
start with ES. Okay.
Titanium.
and then colon, and then a bracket.
Are we
Okay.
writing the 86 above the RN?
Did we do that the last time?
I don't remember. Let me look at my notes.
No.
No, we didn't.
Okay. So we're writing, you said RN?
Those are your class
Yeah.
letter?
Okay, and
And
then,
then after that, the 6s to the second,
is it
and then
6S?
your
Is it 6S to the second?
4f.
7. Is it?
7
Not because
S
we already
to the
passed
second.
radon.
Oh no,
And radon's on the
7,
6th.
7s to the second. Never mind.
7S to the second. Okay, and then, what's after the 7S? We've gotten here,
5F to the 11th.
5F to the 11th. Okay, piece of cake?
Where we don't start at 4F? We go straight to 5?
No, you go straight to 5 because you're in that next row, right? So you go down to here. Right?
Okay.
So it's like, let me show you what it is, okay? The best way of saying this, and I've showed you this before, but I don't think you guys ever pay attention to me. Just ignore me. Like Dr. Henry, you just type noise. That's all he knows how to do. Okay, so this is what the periodic table really looks like. You guys see that? So you look at it. Here's the S orbital. Here's the F orbital, right? So this here is, that would be the 4F down here. That would be the 5F underneath it.
Okay.
So we're here at radon, right? So we did our bracket with radon.
Right.
And then we go to the next level. That's the
This is the
7S.
5.
7S2.
Okay, 7S.
And then that would be 5F11.
Okay.
Because we're talking about that one. Okay, so that, all that is, they put it down there so it can fit on a single page so you guys can actually see it. Because this one is a really long one. And then if you put it on the 8x10, it's so damn small that you can't read any of the symbols. Okay.
Oh, there's 99. Yeah.
Okay. You guys see that?
Yeah.
Yeah.
Okay.
That is easier.
Okay. Okay. So, are you feeling comfortable with electron configuration?
Can we do another one?
Of course we can.
Yeah.
We'll do
Shortcut
one
way?
last. We'll do one more, and then we'll throw some curveballs.
Shortcut.
Okay, so let's do goal. Okay, so what am I going to do for goal?
Where are you at?
Goal. Where's goal? What is goal?
Oh, wait.
Metal.
79.
Are you saying gold?
Gold.
79.
Oh,
I guess I don't emphasize the D enough. Gold. So 79. Okay, so then what am I going to write?
AU,
AU,
and then they call semicolons or colons,
colon,
Two
Colon.
dots.
and then in brackets you're gonna write XE for xenon.
Yep.
Close bracket, and then
Then we go to 1, 2,
6S2.
3, 4, 5,
6S2. That's correct.
6S2.
okay.
And then we go to
4F11.
You
Wait,
said
hold on.
4F11?
Is it 13? Sorry, I didn't count right.
Is it 15 or is it 14? How many does the F orbital hold?
14 because
15.
these should go up here.
That's right. It's
Oh.
14
You're right.
because these two,
Belong up here.
that's right, in that hole. Okay, and then
14, 16.
5D.
Did everyone else's screen?
70. We need 9 more.
5D what? Did you say 9? Did you hear somebody say 9?
Yeah, we need 9 more. So 9.
5D 9. That is correct. Z, are you there? I think we lost Z. Okay, piece of cake. You got it?
Well, I'm getting all these concepts when we do the class, but when I did that one test, that pre-test,
The practice test?
I did really horrible on it. I missed 7 of them. I didn't even fill in 7 of them.
Okay. Well, that's your biggest mistake. You never leave anything blank.
Well, I
That's
didn't
like
think I
asking
did,
for
but
it. Okay, questions, concerns, Cash?
I have a question. For the 4F, why is it a 4?
Because, again, just like the D, remember when we talked about the 3D up here?
Uh-huh.
It's a 4 because it actually starts at the 4th energy level, but that energy level it overlaps with the 6S.
Oh, okay.
So you just want to, take it for what it is. They've measured that energy level. They know that that's the case. So you always want to start. This one is be 4S. This one would be 5S.
Is there a way to know that just by looking at it, or is that something we just need to
Yeah.
memorize?
Well,
Like how can we picture it so that it makes
because each one is going to be one. It's going to be, well, like for instance, the D is one number lower. So D is always going to start 1 minus the level or the period that you're at.
Okay.
So D is going to be 1 minus the period you're at. So if you're at 5,
1 minus 4 for 3.
then it's going to be, exactly.
And then 5
And then
minus.
This guy is going to be 2 minus the period you're at. So here you're at the 6, right?
Correct.
So then if you go 2 minus that, that's going to be 4. So then that's the 4F. Okay? So if we had a G, because normally, like, so right now we're limited by what we know, right? So there's the potential of having other elements that have different atomic numbers, like these guys down here. These guys are all man-made, right? So that's one of the reasons why they're in gray, and they haven't figured out how to make them stable. That's the reason why they have their atomic numbers in parentheses, right? And that's even some of these guys over here. Their atomic numbers are in parentheses because they haven't found true naturally occurring isotopes of those guys that are stable. Okay? So since that's the case, there is the potential of having more chemicals on our periodic table.
because man isn't stable.
Because man isn't stable. Well, we already knew that part.
So
that means that we have the potential of having other sublevels. more sublevels as well too. So the sublevel that would be after F would be G. Okay, so how many? Let's look at the order. Look at it. So S holds how many electrons?
2.
2.
P holds how many electrons?
6.
6. D holds how many electrons?
10.
10.
F holds how many?
14.
14.
Okay, so now I'm going to share something with you. It's ahead of what I'm planning to share with you, but you guys are already picking at the scab there, so I have to tell you, right? So the S orbital, the S sublevel has one orbital, right? One orbital can only hold 2 electrons at a given time. So it holds 2 electrons, the number of orbitals that you have, and I'll explain what an orbital is in a second. If I could spell orbital. If my computer will continue working. Okay, do you guys see it? Is it showing up? Orbital? Okay, so the S has 1 orbital, the P has 3 orbitals, the D has 5 orbitals, and the F has 7 orbitals. Okay, you guys get that? Okay, so an orbital can hold 2 electrons. It can hold 2 electrons. It doesn't have to hold 2 electrons. Okay, so if the S has 1 orbital, how many electrons does it have?
2.
2. If the P has 3 orbitals, what is the maximum a P orbital a P sublevel can have?
6.
6. Okay, so do you guys get that? You understand that?
6 electrons?
That's right.
Okay. 10 and 14 electrons.
Yeah. And so if you think about it, right, it's just divided by 2 because each sublevel can hold 2 electrons.
Oh, yeah, I see it.
Each orbital can hold 2 electrons. Okay.
Okay, I see it.
Okay. So now I'm going to ask you a question. If we found a new element and we go to the G sublevel, because that will be after the F, how many electrons can the G sublevel hold?
18.
Okay, and you figured that out by?
The pattern.
I just noticed the pattern. I don't know.
That's right, exactly, because of the pattern. If we had a G,
So it'll be 9.
yeah, that's right. It would have 9 orbitals, but 18 would be the maximum amount of electrons it holds. Okay, so if I had an H, what would that be?
H would be
22.
yeah,
Okay,
yeah. 11 orbitals.
that's right. Okay, you guys all see that?
Yes.
Good.
Everything's
Okay.
pattern.
Yep, it's a beautiful pattern. You want to keep that in mind. Okay, so you guys ready for moving on? Ready for the next part?
Yep.
So we talked about,
Oh, so,
go ahead, you wanted to ask a question?
yeah, did you already explain what an orbital is? Or
I'm getting there. We're
okay,
working
sorry,
on it.
okay.
Yeah. Okay. So, but before we explain about orbitals, let me tell you a little bit more, right? So we've worked with ions, right? What are our ions again?
They're
Something with
electrically
more or
charged
less-
atoms.
Electrically charged atoms. So how do they become electrically charged?
One's positive, one's negative.
Losing or adding one?
Adding what?
Charge,
Positive or negative.
positive or negative?
Electrons.
Okay, electrons, yes. So either you're gaining electrons or you're losing electrons, right? Because remember, that's what chemistry is about, either gaining electrons or losing electrons or sharing electrons, right? You guys remember that, right? Okay,
Yeah.
you want to make sure you recognize that it's electrons because that's going to be important here. So how's that going to affect electron configuration? So that's what we're talking about next. So if you're losing electrons, do CR
Plus.
3 plus, 3R CR3 plus.
Right.
So first thing that you're going to do is write down the electron configuration for CR. So what is the electron configuration for CR? And we can do it the short way this time. And usually the way it works is you're going to take away from, you're not going to take away from the core, you're going to take away from your valence electrons. So those electrons that are left over, okay? So those are your electrons that are going to be involved in bonding or that are going to be taken away from and things like that. So
Where is the CR?
24.
Oh, there you go, 24.
okay, so what would be the electron configuration for CR?
27. No, 21.
I'm going to ask you again, Lorraine. Listen to what I'm asking you. What is the electron configuration for
24.
CR?
24.
Okay, I'm going to ask one more time. What is the electron configuration for CR?
24.
Oh, shortcut.
It's
Hold
a
on.
setup. I'm going to ask you one more time. What is the electron configuration? I didn't ask you how many electrons there are. I asked you what is the electron
It's gonna
configuration?
be CR dot dot
Okay,
brackets AR bracket, that's 18, S2,
S2?
no,
4s2.
4S2.
4S2, yeah. So that's 4, 18, 20, 22. I need to get one more. And that would be
4S2. So we got this part here.
And then
3D.
3D.
3D4.
3D4. Okay,
3D4.
that is correct. Okay, so now when we're removing electrons, we're going to remove from the highest period first and then downward, right? So what is the highest period that we have?
3D to the 4.
3D4.
That is the highest period? You're telling me 3 is higher than 4? I don't know. I learned to count. I thought 4, if I have $4, isn't that more than $3?
Yeah,
chemistry.
What was that?
4D.
Okay, so isn't 4 greater than 3, right?
Yes.
yeah.
So we're going to remove from here first. And then we're going to remove from here. So we're going to take 2 from here, and then we're going to take 1 from here. Okay? So when we talk about CR3+, and then I'll explain why we do this. We get AR 3D 3.
Listen,
Okay? And that's it. Okay? So let me explain to you why we do this. How many of you guys are parents?
Yeah.
You are?
yes.
Okay.
How many of us are what?
Parents.
Okay.
Okay. So your very first kid, you're like holding on to him with your dear life, right?
Right.
And let's say you get more and more kids, right? And then your good kids, you hold on with dear life. Your bad kids are out running the streets, right?
That's because
Okay.
you taught them how.
There are no bad kids.
That's
What was
right.
that?
Only bad parents.
There are no bad kids.
Just
yeah,
bad
right.
parents.
You can keep telling yourself that one. But anyway, so the point is, if let's say there's a pervert or something like that in the neighborhood, are they going to take away from the kids that are closest to their parent, or the ones that are going to be the furthest away
The
from their parent?
furthest.
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 Why?
They're more
Because
accessible.
they're more vulnerable.
They're more accessible, right? And that's exactly the same reason what happens with the electrons. So 4 is in the outer shell. It's the furthest away from the nucleus, right? And so it's going to be easier to pull away from that one than it is to pull away from the one that's in the third level, right? Even though in energy level, 4 is less energy, right? Because 4 is independent, can do what it wants to do, right? But it's also easier to pull away because it's so far away. Do you guys get that?
Yeah.
Okay. So if you think of it along those lines, you will never forget it. Okay. So you want to try one more?
Yeah,
So
please.
So the 4s squared cancels out.
The 4s
And for the
is
3D
being
4?
removed. Yes.
Okay.
So you're removing those electrons.
So you're removing that one, but for the other one, the 3D to the 4, you're actually just taking away one exponent.
That's right. You're taking one electron away. Don't think of it as an exponent. Think of it as an electron.
Okay.
So are you keeping the
Yeah.
2 electrons from the 4s?
They're being removed, right? Because that's why you're removing 3
So the
electrons.
2's going away
Lorraine.
too then.
What was that?
The 2's going away too then in the 4s.
Yeah, because those are electrons, Lorraine.
Okay, got it.
You're removing those electrons. So you're removing both of those electrons from there, and then you're taking one more from the D.
Okay.
Do you see that?
Yes, I do.
Okay. Okay, so you guys want to try one more time?
Yes.
Yeah.
Okay, so let's do EU 5+. Europium 5+. Okay, so what is the electron configuration for europium first? Let's do that one first, and then we'll do europium 5+. So what do I need to do?
C3? Is that
I'm
the
doing
right
what?
one? Is it
Europium?
63?
63? Okay, so we have 63. Okay?
So EU and then colon.
So that'll be OG. Bracket OG. No. RN.
No, bracket XE.
It is bracket XE.
Why is it XE?
Look where it's at, Lorraine. Look where it's supposed to be. It's that first one. So that means that you go to the 6, you go down here, then you come back up to this guy.
Okay.
Right? So what would be the noble gas before?
The XE.
Okay.
Lorraine, if it helps to think about it, just think about when you see the number for europium, the 63, our RN is 86. So you can see that XE is 54. You can see the order.
Okay.
Yeah.
I see what you're saying. The one behind. Okay, thank you. I appreciate that.
Sorry. You're welcome.
Okay. So we have XE.
6s2.
6s2.
And then 4f7.
That's what we needed.
Okay. So if we're doing europium 5+,
So now we need to take away 5. So would that be 4F? Take away the, no. Six S2.
Would it be 4F4?
that is correct.
That's good. That's very good.
That's right.
And then we cancel out the other 2, right?
Yeah, so you get rid of these 2, right? So then that means that you have how many left? You have 3 left to get rid of. So you have to take 3 away from here. So then that gives you your 4.
Okay. I see where she got it now.
Okay, piece of cake? Okay, so what happens if we're adding electrons?
Then it's going to be -5.
So let's say we have, Te 2-.
Where is it at? Where is it at?
52.
T what?
Te 2-.
I'm still looking.
So it would be Te colon
What's
bracket
atomic number for it?
KR. Te is number 52. So bracket KR. Close bracket. 5s2. And actually, I'm glad you used this one because I'm just trying to wrap my brain around this. I know for the D's we start with 3, right? So it'd be 3D for the first row. Is
Yep.
that the second row would be 3D as well, or 4D?
4D, that's right.
4D, okay.
4D.
Okay, so
4D to the
4D, 10,
Okay.
and then that's P, so it's gonna be
5p to the 4.
5P to the 4, yeah.
Okay. So now if I do the add the 2 electrons, what am I going to do? Is that going to change it?
Gonna add 2 electrons.
Yep.
So is that gonna make it a 5s? I don't know. I don't even want to pretend I know. I'm lost.
Take a guess. You're adding, what are we doing? We're adding electrons. So what are you going to do to it?
So I mean, then, so it'll be 5s4.
Can you have more than 2 electrons in the s orbital?
Oh no.
No.
Okay, so it's still 5s2.
5s2.
Okay.
Don't you add it to the 5
Oh,
P4?
okay. So then the D's.
That's right. You will add it to the last one. That's correct.
Okay.
Because it's added to the end.
Okay.
So it'll be 5p to the 6.
Yep. Or I could write it simply as Te, 2 minus, colon, bracket,
Uh-huh.
xenon. Which is
I still
exactly the
can't
same
find
thing.
TE.
Te is right here.
Thank you.
So if I add 2 electrons to it, 1, 2, it makes it just like the noble gas xenon.
Oh. Well, why was that so simple and all the other stuff was so difficult?
It isn't that difficult. It's all simple.